Let's learn how to find the arc length of a curve using definite integrals. In this case, the arc, a segment of the curve, is approximated by straight line segments whose lengths are given by the well-known distance formula. A curve with a finite arc length is called a rectifiable curve. A sufficient condition for the graph of a function f to be a rectifiable curve is that f' is continuous on the interval. Such a function is continuously differentiable on the interval, and its graph on this interval is a smooth curve. Consider a continuously differentiable function f on the interval a and b. As shown in the figure below, you can approximate the graph of f by n line segments, whose endpoints are determined by the partition. Using delta x and delta y as indicated in the figure, you can approximate the length of the graph. Here, delta x and delta y are defined as follows. The arc length is approximated using the distance formula between two adjacent points. This approximation can be expressed as follows. The reason is that the differences in x values can be replaced with delta x, and the differences in y values can be replaced with delta y. We transform the expression under the square root. This factors out delta x squared. We can simplify the expression further as follows. We factor delta x out of the square root. Let's simplify the expression a bit more. Using the relationship guaranteed by the mean value theorem, delta y divided by delta x can be replaced by the derivative at x equals c, like this. Expressing it in terms of definite integrals simplifies the expression further. The reason is that the first derivative is continuous. So 1 plus f' squared is also continuous, allowing the infinite Riemann sum to be converted into a definite integral. Assuming the function f is a smooth curve over the given interval, the formula for finding the arc length over the interval is defined as follows. Let's consider the following function. Find the arc length over the interval x from 1 to 5. The y-interval is from 2 to 2 square root of 5. First, find the first derivative. Using the power rule, it is 1 over square root of x. Substitute the first derivative into the arc length formula. Square it. And using a calculator, it is approximately 4.7. Let's also calculate for the y-interval. First, solve the given function for x. Second, differentiate x with respect to y. Apply the integration formula in terms of y, simplify the expression, factor out the coefficient 1/2 from the integrand, and calculate. It is approximately 4.7. You can see that the results of the two calculations are consistent. See you next time.